Alright, this is problem number 11, and in this problem we have an equation that's represented implicitly. In other words, explicit, remember, means that the equation is solved for y, or the equation is solved for y in terms of x. In this equation, it would be kind of hard to get y completely by itself, so we're going to use the process of implicit differentiation. Remember, we're taking the derivative of every term with respect to x. So every time we take the derivative of a y term, we leave a dy dx behind, and we're just applying the chain rule to make that happen. So the first thing they ask us to do is to find dy dx. So in letter A, we're going to take the derivative of the first term. The derivative of x squared is 2x. Technically dx dx, which is 1, plus the second term. Again, notice that it is the product rule, x times y. So we'll have the first times the derivative of the second. And the derivative of y is dy dx, plus the second, which is y, times the derivative of the first. The derivative of x is just 1. And then the last term, the derivative of y squared, is 2y dy dx. And on the right-hand side, the derivative of the constant 27 is simply 0. We're going to get all the dy dx's on one side and factor out the dy dx. So I have a dy dx term here and a dy dx term here. If I factor out dy dx, I'll have x plus 2y. I'm going to move the other two terms to the other side, so I would have minus 2x minus y. And in solving for dy dx, we're going to divide both sides by x plus 2y, and so that's my derivative. Now, if this were a multiple choice question, it's possible that they would take the multiply every term by a negative, and you would end up with positive 2x plus y, and then in the denominator negative 2x or negative 2y minus x. But that's not really a big deal. So I'm going to put my answer up here just in case I'm going to need it for the next part of the problem. Negative 2x minus y over x plus 2y. Now for part B, they're asking me to find any points on the curve where the tangent is horizontal. In other words, if you have a horizontal tangent, then the slope of that line would be 0. So what we're really looking for is when is the slope of the tangent line to this curve equal to 0. Now hopefully you remember, and if not, you can go back and review your packets, that if the derivative is going to be 0, here's my derivative up here. If the derivative is going to be 0, I certainly can't let the denominator be 0 because division by 0 is undefined. So if there are any places where the derivative is 0, I'm going to set the numerator equal to 0. Now that does not give me a value, but what it does give me is a line, the equation of a line, that intersects my curve at the point where the derivative is 0. So I'm going to choose one of these two variables to solve for. In this case, I think it's easier to solve for y. So I would add 2x to the other side and then divide by a negative, and I get y equal to negative 2x. Notice I still do not have the points because I'm looking for an x value and a y value, or possibly more than one. So again, this is the equation of a line that intersects my original curve. Now my original curve is up here. So if I want to figure out where the curve and the line intersect, I'm going to substitute negative 2x in place of every y in the original curve. So I would have x squared plus x. I'm substituting negative 2x in place of y, plus, again, substituting negative 2x in place of the y, and then I'll square that. And now I'm going to solve this equation for x, and I'll get x squared minus 2x squared plus 4x squared is equal to 27. In cleaning that up, I would have positive, that would be negative x squared plus 4x squared That would give me 3x squared equal to 27. Divide both sides by 3, and x squared is equal to 9. So x is equal to plus or minus, don't forget about the plus or minus, 3. So the implication is that there are 2 points where the derivative is 0. Now to get the corresponding y values that go along with this, I'm going to substitute back into the equation of the line. So my 2 points would be positive 3, negative 6, and negative 3, substituting back into the equation of the line, positive 6. So those would be the points on this curve where the derivative would be 0 and there would be horizontal tangents. Alright, let's look finally at the next question. We're looking for any points where there are vertical tangents. So in this case, if we have a vertical tangent line, the slope of that line would be undefined. And if the slope of the line is undefined, then we're looking for where is the denominator of the derivative equal to 0. So in this case, for the vertical tangent, I'm going to set the denominator of my derivative equal to 0. So I would have x plus 2y equal to 0. And I'm going to follow exactly the same process that I did before. I would have x equal to negative 2y. I'm going to substitute negative 2y in place of x in the original equation. So I would have negative 2y squared plus negative 2y times y plus y squared is equal to 27. I'll take it maybe one more step. That would give me 4y squared minus 2y squared plus y squared is equal to 27. And I'm going to solve this equation for y, which will give me 2 values, and you can look at the answer key to verify your answer. Once I get those 2 values of y, I'm going to substitute those back into the equation of the line to get the x values. And I'll get the 2 values where the derivative is undefined, therefore there would be a vertical tangent line. Problem number 12, we're looking for the average rate of change. And remember, our abbreviation for average rate of change is ARC. The word average begins with the letter A, just like the word algebra begins with the letter A. So this whole concept of average rate of change is slope, of course. My pen has stopped writing. It wants to do that periodically. Alright, there we go. So this is slope, and it is algebra 1 slope. So for letter A, they've given me the x value of negative 1 and an x value of 2. So my first job is to go and get the corresponding y values in the original equation. So if x is equal to negative 1, that would give me negative 4 minus 1 plus 5. So negative 4 minus 1 would be negative 5 plus 5 would be 0. Hopefully my arithmetic is good there. Let me check it one more time. Negative 1 cubed is negative 1. That would be negative 4. Yeah, that should be good. And for the second value, 2 cubed is 8 times 4 is 32. 2 squared is 4 plus 5. And negative 4 plus 5 is positive 1. And 32 would be 33. So again, hopefully my arithmetic is correct, and now I'm just going to simply find slope, change in y, 33 minus 0, over change in x, which would be 2 minus negative 1. That would be 33 over 3, which is 11, and so the average rate of change is 11. B, they're asking me for the instantaneous rate of change, and that's code for find the derivative and evaluate it at 1. So y prime would be equal to 12x squared minus 2x, and the derivative of 5 is 0. The derivative evaluated at 1 would be 12 times 1 squared minus 2 times 1, which would be 12 minus 2, which would be 10. So that's the average rate of change, which is algebra, and the instant rate of change, which is calculus. In number 13, we're finding the second derivative of each term. So I'm going to do one of these, and then I'll jump into the next video. So 13a, the first derivative would be 3x squared. The derivative of cosine is negative sign, so I'm going to get a plus 3 sine 2x. Now don't forget to take the derivative of the angle. This is a chain rule problem. The derivative of the outside cosine is negative sine, and the derivative of the inside 2x is 2, plus the derivative of ln of x is u prime over u, so I get 1 over x. Second derivative, let me clean this up, 3x squared plus 6 sine 2x plus x to the negative 1. Second derivative then would be 6x plus the derivative of sine is cosine of the angle. The derivative of the angle 2x is 2. So if I take the coefficient of 6 that is already there and multiply it by 2, I get 12. And the derivative of the last term would be, by the power rule, negative x to the negative 2. So my final answer, if I wanted to bring that negative power down, would be 1 over x squared. Let's go ahead and do B. I think I got time for that one. B I'm going to rewrite as 4x minus 3 to the 1/2 power. So the first derivative by the chain rule would be 1/2 of that quantity to the negative 1/2 multiplied by the derivative of the inside, which is just 4. Cleaning that up, half of 4 is 2 times 4x minus 3 to the negative 1/2. Second derivative would be power rule, negative 1 times 4x minus 3, decrease the power by 1, would be negative 3/2 times the derivative of the inside, which would be 4. So my final answer, the 4 would be in the numerator with the negative 1, so that's negative 4 over 4x minus 3 to the 3/2 power, which is, if you wanted to change it to a radical, would be negative 4 over the square root of 4x minus 3 to the 3rd power. And I'll pick up letter C with the next video.